4 astronauts just landed on Mars. Behind them, Earth is over 100 million kilometers away, a pale dot they can't even find without a telescope. Outside the hatch, the air is almost pure carbon dioxide. It will never fill a human lung. Inside, their drinking water was yesterday's urine and sweat. A nuclear reactor sitting quietly a few hundred meters away is the only thing keeping their oxygen system alive. Their food, some of it, was packed and sealed on Earth years before they were born into this mission. If something goes wrong and they radio home for help, the answer takes over 20 minutes to arrive, and then another 20 minutes for their reply to get back. But here's the part nobody tells you. None of that is the scariest thing about this mission. The scariest thing is sitting outside in the dust and the cold, possibly damaged, possibly unfueled, their only ride home. And even if it works perfectly, the planets are in the wrong position to let them leave. For the next 500 days, Mars isn't their destination. It's their prison. Here's something that sounds impossible. NASA might strand its own astronauts on purpose. Not because anything breaks, because of physics. Earth and Mars are like two runners on separate tracks, moving at different speeds. The moment matters because if you time your trip wrong, getting home can cost more fuel than getting there in the first place. So instead of blasting off the second the mission feels done, the crew may be forced to just wait for up to 500 days until Earth swings back into the right position for a fuel-efficient trip home. NASA's own classic mission design lays it out in brutal detail. About 210 days flying to Mars, roughly 496 days stuck there, then 210 days flying back. Added up, that's a 916-day round trip, and over half of it is spent waiting on a planet that wants to kill you. There is a faster option. It's called an opposition-class mission, in and out in as little as 30 to 90 days on the surface. Sounds better, right? Wrong. The trade-off is brutal. Some versions of that shorter mission require flying closer to the Sun than Venus just to catch the right trajectory home, meaning more time exposed to deep space radiation and way higher fuel demands. So NASA is stuck choosing between two nightmares: leave fast and risk the astronauts in deep space longer. Stay long and bet everything on a habitat surviving over a year on a planet that's actively trying to destroy it. They chose to stay. Before we even talk about surviving 500 days, the crew has to survive the first 10 minutes. Every robotic rover we've ever landed on Mars weighed at most 1 metric ton. A human landing vehicle? Over 20 metric tons. That's more than 20 times heavier than anything we've ever safely put down there. Here's the cruel joke about Mars. It has just enough atmosphere to heat a spacecraft to catastrophic temperatures on the way down, but not nearly enough atmosphere for a parachute to slow something this heavy. So engineers are being forced to invent landing technology that has never been used on a human-scale payload. Inflatable heat shields, rocket engines firing while still moving faster than sound, real-time hazard detection while falling out of the Martian sky. And you can't fully test any of it. Nowhere on Earth perfectly recreates Mars. The pressure, the dust, the gravity, the wind, all at once. Out of the last 19 robotic Mars landing attempts, only 12 actually succeeded. Now scale that risk up to a spacecraft carrying human beings, and add one more twist. Landing perfectly isn't enough. If they touch down even a few kilometers off target, away from the habitat, the power plant, the medical bay, a successful landing could still be a death sentence. Here's where it gets genuinely wild. NASA doesn't want the crew building their escape route after they land. The plan is for the return rocket to already be sitting on Mars, waiting for years before any human ever sets foot there. And that rocket needs fuel. Roughly 20 to 23 metric tons of oxygen alone just for the trip home. Hauling that much oxygen from Earth is absurdly expensive. So the plan is to build a machine that manufactures oxygen out of thin Martian air, literally sucking in carbon dioxide and splitting out breathable, combustible oxygen, running completely alone, unsupervised, for up to 3 years straight before the astronauts even leave Earth. We've actually tested this. It's called MOXIE, and it worked, sort of. Across its entire test run, it produced a grand total of 122 grams of oxygen. That's roughly what a small dog breathes in 10 hours. The rocket needs tens of thousands of kilograms. Scaling that up isn't like building a bigger box. It's an entirely new machine with new compressors, more power, more heat control, more ways for something small to break 2 years before anyone's around to fix it. So picture this. Astronauts land on Mars, walk over to their escape rocket, and the only thing standing between them and home is whether a robot, sitting alone for 3 years, kept doing its job. Outside their habitat, no breathable air, next to no pressure, and temperatures that can plunge to deadly extremes. There is no window they can crack open, no delivery truck. Every drop of water, every breath of air has to be manufactured, recycled, or hauled from Earth. Their water system recovers around 98% sweat, breath moisture, even urine, cycled endlessly through filters and pumps that are not allowed to fail. And here's the terrifying part. Redundancy doesn't always save you. If 2 backup filters get clogged by the same dust, or 2 pumps get damaged by the same contaminated water, your backup system just fails right alongside the original. Then there's the dust itself, and it's not simple. It's fine enough to behave like smoke, sneaking into suit joints, bearings, and lungs. It's also loaded with perchlorate salts, toxic chemicals that threaten drinking water, crops, and the thyroid. Yet this same poisonous dust might be shoveled directly onto the habitat roof because it's also their best shield against deadly cosmic radiation. Their protection, their poison, same substance. And their food? It may have been packed years before launch. Vitamin C and B1 can degrade so much that, by year 3, a crew could be eating full meals and still develop a vitamin deficiency. Starvation you can't see on a plate. Now, imagine a medical emergency. Appendicitis, a kidney stone, a dental infection, turned dangerous. 2. There's no ambulance, no hospital, just 3 other astronauts and whatever's in a medical kit. And if it's serious enough to need mission control's help, a message takes over 20 minutes to reach Earth. Their answer takes another 20 minutes to come back. A 40-minute round trip for a decision that, on Earth, would take seconds. Asking mission control for help during a crisis is like mailing the fire department a letter and waiting for their reply. So the crew has to become their own doctors, their own engineers, their own mission control while quietly wearing down. Isolation studies show it doesn't always look like panic or breakdown. Sometimes it looks like less movement, worse sleep, slipping motivation, a slow fade instead of a dramatic collapse. And their bodies are fading too. Mars' gravity is only 38% of Earth's. After 6+ months in transit, losing muscle and bone, they'll land weaker than ever right when the mission demands their bodies work the hardest. After all of it, the landing, the dust, the radiation, the isolation, 500 days of a habitat that can never stop working, there's one final test. The crew straps into that same rocket that's been quietly manufacturing its own fuel, alone, for years. Every system has to work at once. The engines, the fuel, the navigation, the rendezvous with the ship waiting in Mars' orbit to finally take them home. One failure at the very last moment and 500 days of survival becomes a life sentence. Surviving Mars was only half the mission. Leaving it is the part nobody can guarantee. So here's the real question. Knowing all of this, the 500-day wait, the machine that can never break, the escape rocket that has to build its own fuel alone for years, would you still volunteer to go? Drop your answer below. And if this pulled you in, subscribe, because next time we're breaking down the exact machine that has to keep 4 humans alive on a planet that wants them dead.